Hey guys, so this is a review of the functions and it's for the assessment. So by the end of this video, we'll be evaluating functions. We're going to perform some function operations. We're going to do function composition, and we're also going to end with transformations of parent functions. All those skills are going to be on the next assessment. So function evaluation, or evaluating functions, is this f of 4, g of 2, f of negative 4. So what this means is all I do is I take this f of 4 here and I plug it in where the x is. So it's 2 times 4 minus 4, 8 minus 4, so that's 4. So my f of 4 is 4. All it means is I'm just substituting in the x value. For g of x, there are two x's. So I would have to plug in 2 squared minus 4 times 2. Well, 2 squared is 4 minus 8, which is negative 4. So g of 2 is negative 4. F of negative 5, again I switch back and it would be f of negative 5 equals 2 times negative 5 minus 4, negative 10 minus 4, negative 14. Now, the trick, and this is the most common mistake that people make, is this g of negative 3. When I plug it in, I have to put it in parentheses. Well, now I am squaring a negative. Whenever I square a negative, it becomes a positive. And here, negative 4 times negative 3 is a positive 12. So that becomes 21. So you just got to watch your signs there. For f of 0, again, if x is 0, we're just going to be left with negative 4. If x is 0 for the g function, it just equals 0. Okay? And the x's just go away. In our next, these are going to be your practice problems, getting you ready for the assessment. For this one, these are your function operations. So there's the addition, subtraction, multiplication, and division. So for addition, okay, f plus g of x, all I do is I take my f function and then I add my g function. Well, this 3x squared isn't a like term, so I leave it. I then can combine this minus x and this 2x to a plus x, or a plus 1x if you want. And then plus 5 minus 3 becomes a plus 2. And that's my answer. The next one, f minus g of x. Again, I start with my f function. Now I subtract my whole g function. Now this is where people always make the mistake, because I subtract the whole g function. That's why I put it in parentheses. So this doesn't change, but this changes the signs on both of those. I'm distributing a negative 1. So this is minus 2x. Now this is plus 3. So now, again, I combine my like terms. There's no other x squared. I have a minus x and a minus 2x, which is a negative 3x. And now I have a plus 5 and a plus 3, which is plus 8. Okay, you can always tell if you kind of mess up on things because it's usually the second number right here, that minus 3 or that plus 3, that you have a mistake. So if both of your numbers are the same, generally you miss that sign. The next problem deals with multiplication, which requires the distributive property. So I would do f times g of x equals this 3x squared minus x plus 5 times this 2x minus 3, my g function. So what I do is I distribute each one of these to this 2x minus 3. So I would do 3x squared times 2x. 3x squared times 2x is 6x to the third. Okay. Then I do 3x squared times negative 3. That's negative 9x squared, because the x's don't change, there's no x. Now I distribute in this negative x to this 2x minus 2x squared. Whenever I'm multiplying two x's, there's an x squared. And then negative x times the negative 3 becomes a positive 3x. And then my final is the last 5. 5 times 2x is 10x. 5 times negative 3 is negative 15. Now I just combine my like terms. Well, there's no other x cubes, so it's 6x cubed. I combine my x squareds, it becomes negative 11x squared. I combine my x's, and then I just have that one number. And there is my answer. Okay. The last one is my f divided by g of x. This is generally the easier one because I can't really do anything. So it would be 3x squared minus x plus 5 divided by 2x minus 3. The one thing that I have to say is I can't have this bottom be 0. So what I do is I say, okay, well, 2x minus 3 can't be 0. And I solve it like an equation. Plus 3, 2x cannot be 3, divided by 2, x cannot be 3 halves. Because if x is 3 halves, this bottom part's going to be 0. So I would just say x cannot be 3 over 2, or 1.5. Okay? So that's function operations. Function composition. Oh, these are the next practice problems. Function composition just is a big word for substitution. So g of h of x means that I'm going to take my h function and I'm going to plug it in to my g. So 2 times x plus 2. Well, that becomes 2x plus 4. And that's my answer. The reverse of it is h of g of x. That takes my g function, my 2x, and I plug it in there. Well, that just becomes 2x plus 2. And that all it is substitution. The trick comes with problems like number 10 here. The g of h of x, again, takes the h of x and plugs it in for x. So it's just 2x squared minus 3 plus 2. I simplify, it's 2x squared minus 1. Well, the problem comes when I do my h of g of x. That's when I'm taking my x plus 2 and I'm plugging it in to my x. Well, that becomes 2 times x plus 2 squared minus 3. Now, this is the tricky part, because it's not just x plus 2 squared, so I square both of those numbers. Whenever I square something, it's x plus 2 times x plus 2. So what I have to do is I have to do that distributive thing, just like I did with multiplication. So I have to do the x times the x, which is x squared, x times the 2 plus 2x, the 2 times the x, and the 2 times the 2. Now I can simplify these. Now that is that x plus 2 squared. So I can distribute 2x squared plus 8x plus 8 minus 3. I can combine those to 2x squared plus 8x plus 5. So that is my composition. And that only happens when it's squared. So it wouldn't happen here. It wouldn't happen here. It is going to happen in 10, where I have to square that x plus 6. Okay. In the last part of the test, or the assessment, is going to be on function transformations. So when you see something move up like this, well, first off, this is quadratic, so it's going to start off with x squared. Well, and then it just moved up 1. So this is really x squared plus 1. Well, here, again, it's still quadratic, but now it's wider by a whole lot. So, really, you can kind of estimate, okay, that's really like 1/2 x squared. And again, it's like an estimation. How much wider is it? Okay, how much up did it go when I went over one box? About a half, maybe a quarter. It's up to you on how you guys want to do that. So that's how you're going to do these next problems. Is remember when it moves left or right, it's the h. When it moves up or down, it's the k. When it gets steeper or wider, that's the a. So just to review that, okay. If I have a y equals or an f of x equals a parentheses x plus h squared plus k, remember a plus h moves to the left, a minus h moves to the right, a plus k moves up, a minus k moves down, a positive a, okay, an a that is greater than 1, 2, 3, 4, something like that, makes it narrower, okay, an a that is less than -1, okay, anything that's negative flips and makes it narrower. Okay, any decimal or fraction, any a that is between 1 and -1, any fraction makes it wider. You can think of the a as the slope. Okay, whenever it's a fraction, the slope kind of levels out. Whenever it's a big number, it kind of steepens. So that is the review for the functions. Make sure that you come in with the practice done and you have your notes ready.